Alrighty guys, welcome to your 39th video, and in this video, since these are physics lessons, I thought it would be more appropriate to show you guys an example of the last formula that we learned, but apply it to a topic that's a little more physics related. Because, surfing in Hawaii is fun and all, but this formula, velocity equals wavelength times frequency, it actually works for a bunch of different types of waves like radio waves, light waves, sound waves, not just surfing in Hawaii waves. So let's go ahead and take a look at a basic sound wave because I think that this will be the easiest wave to demonstrate on. So sound waves, before we just jump into the formula, let me go ahead and give you a little background. First of all, the frequency of a sound wave is often measured in hertz. And a hertz is basically one cycle per 1 second. So instead of, figuring out, hey, scientists, do you want to measure in minutes, hours? What about you over there? They just said, you know what, we better standardize this. Anytime we write hertz, it just means it's basically a very common unit for frequency, and it means one cycle per second. So another thing is, well, let me just go ahead and what makes sound? We'll say that a guitar. So let me draw this guitar right here. Not a bad guitar. Here's a little blowhole or whatever you call it on an acoustic guitar. Here's the neck, and might as well go ahead and finish this thing off. Here's the head, and something tells me that this guitar is going to look like a dead alien that just got shot. And let's see, what else does the guitar have? Some frets, some strings, good enough. So basically, whenever you pluck a guitar strings vibrate at around 500 hertz. So they make 500 vibrations every single second, which is incredibly fast. Now, here are the sound waves coming off the guitar. Pretty realistic sound waves. Now, the sound waves, the distance between these different waves is often around 0.7 meters whenever we're talking about sound. So I know that a lot of times that my examples are way far off, what they normally are, but this is, somewhere in the range for a typical guitar plucking. The frequency is often somewhere in the area of 500 hertz, and the sound waves are usually somewhere around 0.7 meters apart. So just remember that 500 hertz and 0.7 meters because I'm about to hop to a new slide. So remember the formula, I'll write that again. Velocity of any wave, including the sound wave, is the wavelength multiplied by the frequency of the wave. Now we know that the wavelength of this guitar, the sound waves, is 0.7 meters, and the frequency equals, I think we said 500 hertz. So now, if we wanted to calculate the velocity, what would we do? Well, velocity is equal to the wavelength, which is 0.7 meters, multiplied by 500 hertz. And remember, you don't have to write meters or seconds because that's what hertz means. So now, when we multiply those two figures together, we get 350 meters per second. So if anyone ever asks you, around what speed does a sound wave coming from a guitar, how fast is that? You can say with confidence, probably around 350 meters per second, which is actually really fast. It's almost, actually, I want to say like a commercial airplane is probably 320, 330 meters per second. So sound waves are slightly faster than a commercial airplane. And a fun fact, I know that a lot of you guys probably know that really fast jets, like the kind the Army uses, can break the sound barrier, which basically means they can go faster than sound waves. But some super fast jets can break the sound barrier many times over, and they can do it with ease. And maybe we'll talk about sonic booms and the sound barrier later on. But for now, just remember this formula applies to other things except surfing in Hawaii.